Today we're talking about physical and chemical changes. We're going to be using our slides to fill in our notes. You should have your Google Doc pulled up so that we can work on getting your doc filled in using this video and getting your notes together. Physical changes occur when the appearance or form of a substance changes, but chemically the substance is the same. We are not changing the molecules. We are not making something new. We are literally just changing the way that it looks or feels. So simple examples may be changing the state of matter. So we could melt something, we could freeze something, we could boil it, we could condense it, we could also cut it into smaller pieces. Essentially, there's a million different examples. That's essentially what you're doing, is you're breaking it into smaller pieces, or you're changing its shape or the way that it looks, but you are not making anything new. So taking a piece of ice and melting it into liquid water is not making something new. It is still water, whether it is frozen solid or whether it is liquid. Sometimes we're also going to mix things together and something will dissolve. So for example, when you're making Kool-Aid, you're going to dissolve sugar and the Kool-Aid packet into the water. Those are physical changes. They are not chemical changes. Making salt water, mixing salt into water, getting ocean water. That is a physical change. You are not making something new. These substances will keep their original properties and can be separated again. When we talked about mixtures, we said that the individual parts maintain their properties. So water will still be water, sugar will still taste sweet. We're just mixing it together and making sweet sugar water. But if I evaporate the sugar, evaporate the water, I'm still going to get the sugar back. So here are some other examples of physical changes. I could crush a can. Again, we're just changing its shape. I could melt an ice cube from solid to liquid, changing its state of matter. Boiling water is changing its state of matter. Mixing sand with water. They don't even dissolve together. They literally separate as a heterogeneous mixture. They are going to both maintain their properties. Breaking glass, making smaller pieces of glass. Taking dry ice, which is frozen carbon dioxide, and when you put it into air, it will just start to immediately change into a gas. It will skip the liquid state. That's sublimation. That's a change in state of matter. It's a physical change. Mixing marbles together, again, they don't even really combine. They're just together in a pile. So they're going to maintain their physical properties. They're going to be a physical change. Chopping wood is just breaking it into smaller pieces. Physical change. Shredding paper, making it into smaller pieces. Physical change. Dissolving sugar in water. Again, we're maintaining our physical properties. They're just mixed together. So that's going to be a physical change. A chemical change will be when the atoms making up the matter are going to rearrange to form a new substance. You'll have new properties. So again, the key word here is new substance. So usually you'll have some kind of chemical reaction. The thing to remember is that a chemical change has not actually taken place unless matter has changed into a new substance. So if you're not making something new, you're not undergoing a chemical change. So rusting, tarnishing. Tarnishing is when the silverware, it's literally ruined. There's a chemical reaction and the silverware changes color and you can't clean it off or anything like that. It's just the metal has literally changed. Burning, again, you're making a new substance. We talked about making ash when you're burning paper. Cooking, you're making a new substance. Digesting food. What goes in does not come out the same way. That's making a new substance. Evidence of a chemical change. Now on your Google Doc, you should be in the evidence section. So we're going to sometimes you can produce a gas. So what you might see is bubbling or foaming. You'll have a smell. You might see fizzing or smoke. We saw that with the burning paper. We may have a color change. Keep in mind, though, not all color changes are chemical. If I add food coloring to something, that's a physical change. But many times a color change in combination with some of these other things will be a chemical change. Will obviously change color. Formation of a precipitate. So when you mix two things together, a lot of times when the chemical reaction occurs, you make a new substance. You'll have this solid lump at the bottom of the container. It may look cloudy. It may look foggy in the test tube. But that's called a precipitate. That's a chemical change. Change in heat or light energy. So basically something will get warmer or something will get colder. Either it will get brighter or dimmer. So sparks, explosion, glowing, again, or getting dimmer, it's getting colder, something like that. So will be a change in heat or light energy. Okay, and then again, here we have several examples. Iron rusting, again, the rust is a new substance. Burning wood, you're turning it into ash, new substance. Metabolism, again, what goes in does not come out. It's a different substance. Cooking an egg, my new egg, there's no way I'm going to go back to a raw egg. That's how I'm done. Baking a cake, same thing. There's no way to separate that sugar and that flour and the eggs to go back to the initial ingredients after you bake it. Electroplating, so when you use electricity in a liquid and you're causing something to stick to another substance or another metal, that's creating a new substance. Banana rotting, again, there's no way you're going to get the initial ingredients back. It's done. It does not, and you know that it does not taste the same when a banana starts to go bad. Vinegar and baking soda, we did this together in class. You know that it fizzes and it bubbles and it creates a gas. We also talked about how the flask got really cold. Fireworks are going to be, again, an explosion. You're going to see sparks. You're going to see glowing. That's a chemical reaction. And then again, if you make a chemical battery, so you put electricity into water, you can make a light bulb glow. So all of these things are chemical changes. Remember that you're making a new substance. The initial substances are no longer the same. You made something new. Please make sure that your Google Doc is totally filled in. You need to make sure that you look at the questions on the bottom of your Google Doc. Is burning a candle a physical or chemical change? Justify your answer. So remember when we talked about burning, what that means. Number 2 says a student puts water in a beaker and heats the water. After a few minutes, he observes the bubbles forming in the water. He concludes that a chemical change is occurring. Evaluate the student's conclusion. So, carefully read what he did. We said that he puts water in a beaker and he heats the water and he sees bubbles. So, go back to your notes and look and see if that's a physical change or a chemical change, and then explain in the box.